So, building on what we talked about in our previous lesson with empirical molecular formula, quick review. Empirical formula again shows the compound in its simplest version, the simplest whole number ratios that the elements in that compound can exist, whereas the molecular formula shows you the actual number of each atom, or the actual number of atoms of each element. Just a quick note that ionic compounds are always empirical, just because they only have one possible combination because they form from the transfer of electrons. Now, today we are going to take empirical formula one step further. In these examples, you are going to see how to calculate empirical formula using experimental data. For example, given that a certain compound is 69.58% barium, 60.090% carbon, and 24.32% oxygen, calculate the empirical formula. Step one, when solving a problem like this, is to assume that you have 100 grams of the compound. By assuming that we have 100 grams of the compound, we're able to just change percents to grams, because we know that all of our percents add up to 100, so now all of our grams will add up to 100. So we have 69.58 grams of barium. We have 6.090 grams of carbon, and we have 24.32 grams of oxygen. Now, I have the steps written out separately, but feel free to do your work together. You don't have to write everything over for each step. So for step 2, it says divide the mass of each element by the molar mass. So our molar mass, again, comes directly from the periodic table. So if we look at barium, it has a mass number of 137.327 grams per mole. If we look at carbon, it has a mass number of 12.011 grams per mole. And if we look at oxygen, we have 15.999 grams per mole. Our grams cancel out. We divide each of these. So 69.58 divided by 137.327 will give us 0.51 moles of barium. 6.090 divided by 12.011 will give us 0.51 moles of carbon, and 24.32 divided by 15.999 will give us approximately 1.52 moles of oxygen. So we just did step 1, assume we have 100 grams. Step 2, divide by the molar mass. And then in step 3, divide each answer by the lowest. So I want to rewrite this. This is the way I like to set these up in terms of formatting, and I would encourage you to try the same just to make it clear. For barium, I'm going to take the 0.51 and I'm going to make it a subscript. For carbon, I'm going to take the 0.51 and make it a subscript. And for oxygen, I'm going to take the 1.52 and make it a subscript as well. We are going to divide each of these by the lowest, I should probably say value instead of answer. But 0.51 is our lowest, so we are going to divide each of these by 0.51. For barium, 0.51 divided by 0.51 gives us 1. For carbon, 0.51 divided by 0.51 gives us 1. And for oxygen, 1.52 divided by 0.51 gives us approximately 3. So in this case, our empirical formula would be, sorry for the line, would be BaCO3. Second example, an ion containing only oxygen and chlorine is 31% oxygen by mass. What is the empirical formula? So again, we start with the same steps. Assume that we have 100 grams. I'm going to try to do everything on this one side so we can see it all together. So we're going to say 31 grams of oxygen, but we need to know how many grams of chlorine as well. We know that everything has to add up to 100. So chlorine plus oxygen must equal 100. So that means if oxygen is 31, chlorine plus 31 equals 100, we can just subtract 31 to know that chlorine is going to equal 69. So chlorine is 69 grams. We divide each one of these by the molar mass from the periodic table. For chlorine, the molar mass is 35.453 grams per mole. And for oxygen, it is 15.999 grams per mole. Our grams cancel out. For chlorine, again, I'm going to write this as a subscript when I divide. 69 divided by 35.453 will give us 1.95. And for oxygen, 31 divided by 15.999 will give us 1.94. 1.94 is the smallest value, so we're going to divide both by 1.94. And that will give us both a subscript of approximately 1. So that will be ClO, which would be choice A. Now, something that you didn't see, but it might happen, let's say that you divide, and at this final stage, instead of Cl1O1, you got Cl1O1.5. If you have a 0.5, we can't round up. That's just rounding too much. What you would do is you would multiply each of these by 2. So this would become Cl2O3. Let's say you got Cl1O1.3. If it's 0.5, you multiply by 2. If it's 0.3, you multiply by 3. And this helps us get whole numbers. This would become chlorine 3, oxygen 3 times 1.33 would give us 4. So 0.5 multiplied by 2, somewhere around 0.33, 0.34, you would multiply by 3 to get rid of that.